Hello, I'd like to give you a short impression about how COMOS can integrate and support the different kind of life cycle phases from process and plant design, how COMOS can support during engineering and commissioning, and during operation, maintenance and optimization. Let's start with the process and plant design, where the process engineer often are using thermodynamic simulators to do a proper plant layout and handing over this data into COMOS, creating the process flow diagram with all the equipment streams. So therefore, simulators like Aspen, Pro2, HYSYS are used, and GPROMs may also fit into this region. So let's go here for the min case and let's import the data. Getting here for the min case, so for a proper plant layout, the data and all the equipments. And COMOS now distributes this information to all components inside of this process layout. This brings us now from the process and plant design into the engineering and commissioning lifecycle phase. Here the mechanical engineer is guided to select the default equipment or rule-based solutions how to realize this reactor and all other equipments. Based on this template technology, the system creates all the detailed information necessary for the basic, extended basic and detail engineering. Here we find a seamless handover from the imported Aspen data for the min case into the engineering phase, into the basic engineering on our pipe, and further and triggering with this routes how the system should now manage all these inline components and creating therefore also for the 3D world like geometry data or flange sizes and types. So down to detailed information like the isometrical drawing, which is used for manufacturing the piping components. So the template also brings in information concerning the power consumption for this motor with this data, and let's do a short calculation. That brings us to the layout of our switchboard here on our single line diagram. And now we have got the view for the different kind of engineering disciplines, from process or mechanical to electrical and detail electrical. And if you make a modification, changing agitator 1 to 1A, then it's still MO1 on agitator 1A, MO1 on agitator 1A. So bidirectional changing somewhere inside of the system. You've got data consistency wherever this information is presented. Drive for the process engineer looks like this on a single line diagram, and on the detailed circuit diagram like this. It continues to all areas, jump to the cabinet layout, into the 2D views, but also into the 3D view. Our reactor template already comes with a lot of instrumentation information, the different kind of valves. But if we need another instrument, we can just grab one out of our library and bring it into the system for, in this example, interlocking this inlet valve. Behind of our instrument, also the wiring information from sensor, junction box, marshalling area, up to the control system. And here we have got the IO 540 belonging to our ET200 SPHA. Comes with this assembly plan, but also, so here on our configuration plan we see the overall architecture with the station, with servers, engineering stations, operator stations. Next to the hardware view, we also have got here software view, so the signal we will find on our functional diagram, on our control module for analog monitoring. And the job here should be to interlock this inlet valve, as we can see it here. This brings us to the integration to the PCS7. Export now the plant hierarchy, the control modules and the hardware into the PCS7. We now have got our station with the redundant CPUs, ET200 SPHA, and our pressure is on address 514. And our control module for our pressure transmitter, where we can bring in the ranges we will find the interlocking information and also may bring in further kind of functions time delay. These changes can be handed back into the COMOS documentation and are directly inside of our documents and following here the signal to the inline valve. Also here we are getting this time delay back. For commissioning purposes and simulation purposes, we may now hand over information out of COMOS into the ZIMIT, so hand over the technological hierarchy, so the DCS structure, but also having here the field ID export and also the interface configuration with the ZIMIT components and the needed component mapping. And now let's switch to the next life cycle phase. After engineering and commissioning, we see the operation, maintenance and optimization. Here we specify for our equipments the different maintenance strategies, repair strategies, covering the work packages, the different tasks and the needed resources we're going to perform with these kind of tasks. Further to this, the operator can smoothly identify where his equipment is located inside of the 3D world and directly navigating into the 3D world, getting impression about where the pump is located and what kind of documents are available. The manual, for example, may be of interest, but also training scenarios can be scripted on top. So what the operator needs to do when maintaining the pump. The field workers want to access this data mobile. Therefore, we have got the COMOS mobile worker where the data can be accessed, having the engineering structure with all kind of documents, P&IDs, equipments, data sheets behind the equipments, MRO information, events, repair information, work packages, and the task which needs to be performed. As an authoring application, we hand over this information to plant side for the tech register, so the plant hierarchy, for example, all documents, equipment information to aggregate, and the contextualization, maybe with operating data, so completely integrated. That's it.